Right. Thank you, everybody online. We do have a few people who have joined. This is nice, exciting group of people we have. This is one of our bigger attended events, this year. Thank you, Elastic, for sponsoring today's talk. We're excited to have Mark here to talk about how AI can help improve, our mean time to recovery and some other metrics that'll be key for pretty much everybody. We have use cases in security and operations would as well. Make sure Mark can share. The slides that I'm currently sharing, just as I do, maybe a quick announcement for anything. I do have some links that I can share in case you want to share them with your colleagues. We want to keep growing, so please do pass our paper call, YouTube, the meetup page, everyone to your teammates. If you manage a team, we'd love to have people who are looking for opportunities to speak and grow. We'd love to have more of the community come in. This doesn't have to be a vendor sponsored kind of event. And Linda shared a really good link that I want to make sure I plug here. One of the slides I can switch to will be the Summer of Cyber Ranges. It's a command and control, kind of capture the flag that'll happen over the course of the summer. Security Innovation was another gracious sponsor we had last year.
Can I say, so that one is, Security Innovation, but Command and Control split off from Security Innovation for their training. So they're starting their Summer of Cyber Ranges, starting next Thursday evening is the first one, is the kickoff. So yeah, Jeremy's got the link in here for anybody who wants to join.
Yep, I will share with everyone who wants to join. Linda beat me to it. They're Command and Control, separate subsidiary. They were Security Innovation last year, but they helped us out, and we want to make sure that they get that. We plug their event because it'll be a really fun free training opportunity for those of you who haven't done it.
I just promised them that I would plug it. So
now it'll be on YouTube, so there's proof. With that, if anybody has any questions or anything for me that we can answer kind of before we pass it to Mark to get started, I'm happy to answer. But thank you, everybody, for coming.
So thank you, everyone. I'm going to let Chris kind of start off here as soon as I share my presentation. We have a brief presentation, and then we'll go directly into some demos, if that's okay with everyone. Let me find the...
Yeah, we'll keep the slides short. No one likes death by PowerPoint, so we'll be brief and get through this quickly. Show of hands, who here knows Elastic and has looked at us recently? Let's say recent, within the last year or so. Okay, so quite a few people haven't seen us in a minute, or not at all, so, okay. I don't mean to shame anybody either. I'm just trying to get a feel for where everybody's at. You can go ahead, Mark. Okay. But yeah, we are Elastic. We really appreciate you guys having us today, and keep going. Keep going. There we go. Keep going. There we go. Okay, cool. So Elastic, we've been around for a while, guys. We were founded back in 2012. Well, we became incorporated in 2012. We were actually created a little bit before that. Our founder created Elastic as a way for his wife to store her recipes as she was going to one of the really famous French cooking schools. And so he's over from in the Netherlands, and his wife is from that area too. They still live over there. But anyway, Elastic's an interesting animal. So we're an open source company. So we really believe in community. We believe in letting people have access to stuff. And we give to other open projects as well. We're one of the biggest contributors to Open Telemetry, for instance. I'm sure some of you guys are familiar with that. But they actually adopted Elastic Common Schema as their own. So the way that we do our schema and our indexing is what Open Telemetry is using now too. We are used by the top half of the Fortune 500. So there's a lot of companies that trust our software for different problems that they have. But really, we solve any kind of data problem that you can think of. At the end of the day, when you're trying to solve a problem with data, you're just searching, you're looking for the right information. And so how do you find the right information, and how do you find it quickly? And that's what Elastic solves. So as I said, we started with search, right? That's our bread and butter, and that's where our roots are. Now, if you think about it, observability and security are really just search problems. You're trying to find the right information for security, for instance. You're trying to find the right logs, the right events, the right combination of data to tell you a story about what's going on in the environment and determine, is something really bad happening or not. And so we've been able to layer on analytics pieces on top of the search part in order to provide a solution around security. Same thing for observability, right? I want to know how my applications are performing. I want to know how network is going, things like that. And we're able to answer those questions for you. But we've got two great solutions in security and observability that are ready to go right off the shelf, while search takes a little bit of love to get going, because you've got to build a little bit of a solution around. If you want to continue, Mark. But a lot of people know us as ELK. We have Elasticsearch, Logstash, and Kibana. We're now just called Elastic. So for those of you who have known us as Elk and that kind of thing, that's all over with. Our marketing department is very adamant. We are Elastic, and that's it. They're also very adamant that we are the search AI company. So I love some of those terms. But keep going.
Wait, can I ask a question?
Yeah, please.
Search AI. So does that mean using AI to search, or are you searching like AI models and things, or what does search AI mean?
Now we can get really deep in this and get philosophical. So what do you mean by AI, first of all? Are you talking about an LLM, or are you talking about
Well,
machine
you're
learning
search
model?
AI, so you tell me. What do you mean by AI?
I think what they mean by ours is, using a large language model of your choice, and using any other kind of models for sorting data in order to search through large amounts of data quickly, right? Elastic is able to do hybrid and semantic search really well, which means that we can understand the intent behind a question that gets asked, and we can do that right off the shelf. So, if you ask a question, for instance, like, is my side hustle, like, what would happen if I have a side hustle at work? Most of the time, a search engine wouldn't understand that, right? It would go in and it would look for keywords and try and match up side hustle to some kind of documentation internally. Well, with Elastic, it's able to actually determine, from side hustle, that means that the person is talking about a secondary job outside of their primary job. Let's search the documentation for that instead. And so from an AI perspective, it's able to kind of understand natural language a little bit better. But I hope, does that answer your question?
Yeah.
Okay, cool. But yeah.
I'll go into depth, and actually I'll use that exact example. We'll see if it works or not.
All right.
Yeah, and so today, actually go back one. Today, Mark is really going to talk about the observability side of the house. I know a couple people had questions around the search piece, and I think we're going to hit a little bit of that too. I'm just curious if anybody else has done research into Elastic, and if there's anything else anybody wants to see today. Any questions around security or observability in particular that anybody has, things that you might want to see?
So I'm going to ask the question around AI.
Yeah.
Do you guys have your own models, or are you using ChatGPT's LLM and then train those models based on the data?
So as of 9/1, we are shipping with an LLM already plugged in.
Can you repeat the question just so everybody
Yeah, no
online can
problem.
hear it?
The question
Sorry.
was, do we have our own model, or do we use external models? And the answer to that is, as of 9/1, we're going to ship with our own LLM already on the back end and installed and everything, so that you can use our AI assistant and all the AI functionality. But Elastic is flexible enough for you guys to use whatever model you want. We can do a locally hosted, we can do something hosted in Hugging Face, any combination and anything you want to do from a model perspective, we can use that and bring it into Elastic. So we try and be agnostic and make it easy for you.
Is it going to be that feature? It's going to be available on that community version as well, or is it going to be only for like enterprise version?
Yeah, it has to be enterprise version, because the LLM, it has to be hosted. And so in order to have an LLM, that you have to have huge amounts of compute on GPU.
Yeah.
So that obviously costs and stuff.
Yeah.
So unfortunately, it's not going to be free, but
Yeah.
the advantages of using it are that for customers that are new to AI and they don't know how to use it, it's already connected and set up. So there's no setup at all on it. It's already up and running.
Well, that's for the AI assistant piece, right? That's for our little agent that we have that'll answer questions. But if you're doing things external to Elastic, you can still use the open source version with models that are hosted somewhere else. So we're still able to act as the vector database for a model that you've got hosted in Hugging Face or something like that.
Sure, you can still do vector search with LLMs, but if you're leveraging like RAG or prompting and stuff, you probably kind of need an AI connector and stuff, and that's what we'll offer, a default one.
I was gonna ask that about RAG, so appreciate it.
Yeah, actually, what I think I'll do is when we kind of get the intro and stuff, when I get started, I'll probably get started with a use case to show how our search and that machine learning and vector and all our AI connections work. So we'll start out with that and then we'll apply it to a use case real quick.
Yeah, no, it sounds good. Didn't mean to hijack your talk though.
No, this is great. I love conversations versus me just spewing a bunch of BS, so.
It might be a question that we get to during like demo time, but Chris online has asked, is Elastic compatible with Apache Iceberg on AWS?
Mark, I'll leave that one to you. That's a very particular combination.
Yeah, I'm not sure. I've not had that question asked. When they say compatible, does it mean compatible to ingest telemetry from or to run on top of that?
I would imagine run across that data set. Yeah, or ingest that data.
Yeah, absolutely. I mean, I know we have native Apache integrations. And I'll show that too. And as a matter of fact, I'll use Apache as the search that I'm looking for. But I don't know the particular Iceberg. I'd have to look. We have Apache integrations, but I don't know if there's a difference between Apache and Apache Iceberg or not.
Okay.
But if we don't have an integration, we can take in any telemetry. And it's a different, go ahead.
So I used to use the ELK stack back in the day to capture telemetry from applications I was running.
Mhm.
And it was just something, we put together with the stuff. From a platform perspective, when you're talking about the platform, the solutions that you have, what's the difference between that and what I was doing, the solution that you're putting on top of it? Is it kind of, what makes it specific to security, for example?
Well, we've made it a little easier for users on that use case. So for instance, like all of our rules, they're ready to go right off the shelf. They're all connected to MITRE. We've got dictionaries that update all the time and the machine learning jobs that run to figure out if something's really anomalous or not. That's all just right there in a wizard for you to play with so that you can configure that for your environment. So, all right, I guess the answer is we've made it easier end to end to get from bringing data in to determining if there's an attack. And we've put all that in our platform so that you don't have to go outside and you don't have to build anything. Does that answer your question a little bit?
It does. And I assume is it like you have the picture of the globe thing, so it's like a SaaS-based kind of solution?
Yeah, we have a bunch of different flavors. So we've got self-hosted where you can take us, deploy us in your cloud, on-prem, whatever you want to do. But you have to manage all that. You've got to feed it, grow it, and everything. Then we've got our cloud hosting. We've got our PaaS solution where it's a platform as a service. We're handling the infrastructure behind it, but you've still got to manage Elastic and all the upgrades and things like that. But we also have our SaaS solution where it's more outcome based. And we're managing the Elastic deployment so that you don't have to worry about it. You just point the data at it and we handle all the indexing and the sharding and all that behind the scenes.
Okay, thank you.
Yeah, no problem. Next one, and I think we're close to the end. So we're totally agnostic for data, right? Like we don't really pick a horse. We don't side with any one particular company. We've got partnerships with Google, AWS, and Microsoft, and we can be deployed in any of their cloud environments. So we're super flexible. We're really agnostic, and we can go live wherever your data is, which I think is a big benefit and prevents you from having vendor lock-in and other problems like that. Like I said, the top half of the Fortune 500 are using us, and there's a lot of big names up here. A couple that come to mind is Home Depot. We are managing all of their inventory on their application. So if you guys have ever gone to the store and used the app to figure out like what aisle and what bay something is in, there are millions of queries hitting that at any one given moment in time. It's pretty cool. There's millions of queries per second. We're able to handle that, still give people real-time updates. But we are also the basis for their chatbot assistant. So if you go to the website, you know, and you're asking questions like, what do I need to build a deck? Elastic is what's interpreting that and finding all that data for you on the back end. Yeah, I think that's about all I've got. So I will leave it at that. Any other questions from anybody? Any comments? Any cuss words? Awesome. Well, thank you guys.
Yes, thank you.
Thank you,
Let's-
Chris.
Let's see the fun stuff now.
All right, so I have a few slides on network telemetry, but I'm gonna hold off on those first because what I'd like to do is go into a couple of deployments and show you some examples. So I'm gonna go into Eden, which is kind of our demo use case, and I'm gonna launch so what this is just a React front end, which React is kind of like just a quick web front end to be able to build this interface and test things out. And so you can see right here, in this particular example, I'm connected to Azure OpenAI and ChatGPT, but I have the ability to connect to whatever I want. And notice the private one right here. This is just like if I want to actually run our private LLM that comes with the solution, totally wrapped into it. So what was his question? Can I have a side gig? Is that what he said? I can't remember.
Oh, no, does the company own my side hustle?
Side
It was-
hustle.
Oh, yeah, does the company, okay, there it is, right there, okay, well, that one's there, so let's try something different. Okay, so I'm gonna say, can I put my puppy under my desk? What am I asking? Anybody?
Your pet to work.
Exactly, perfect, that's exactly, and so what this is this is a React front end that is tied to live, Elastic, all of our policies, company policies. So if you're wanting to find out when can I take leave for a wedding, any of those questions up there, examples, or can I put my puppy under my desk? I'm hoping that Elastic has a policy on if I can bring my dog to work or not. So let's look and see. And so it'll go through and it'll say, give me my answer. Yes, you can put your puppy under your desk as long as it complies with the office pet policy. And I can see right here that this particular policy was a SharePoint document. Okay, so this was just a connector to our SharePoint repository. It doesn't matter if it's SharePoint, GitHub, Jira, anything. What we do is we connect to those, we ingest the data through an ingest pipeline, and then we vectorize it through an LLM. So we're leveraging semantic search on it so that when I search for something, I don't have to do a lexical search, which means something in my query has to be in that document. So if I open this right here, this is the title, this is a portion of the pet policy. And I think it's the whole thing right here, or maybe the snippets that my results came from, that's what it is. So if I do a Control F and I say puppy, you can see puppies in my query, puppies in my answer, but puppies nowhere in the document, right? It's not here anywhere. So how does that work? So if I go back and we look at the Elasticsearch indices in this particular deployment, this is where we can actually see how we've set up our connectors to our documents. So if we look at our indices right here, I think Workplace App Docs is the indices that I'm looking at. And if I go into all the documents that are connected to it, I can actually look at this and I can say pet policy, and it's one of the first ones here. So notice what's happening here is I am taking the fields that are in the document, the metadata that's in the document, and I'm actually using a dense vector ingest pipeline right here. And notice I'm getting a numerical value. So what happens is that I take all my documents and I vectorize them into numeric values. And then when I take a query, I run that query against the same ingest pipeline, vectorize it too. And then I use either cosine similarity or HNSW graph to find all the words that are closest to the mean I'm looking for. Now, how would you solve this in a lexical use case without semantic search? Let's say you're an e-commerce site and I say, I need a new parka, but all you have is coats. What would you do? Anybody?
You look for the
Synonym.
word.
That you can answer, you start using synonyms. So for people that have actually, they do this for a living all day, they sit there every day and they put synonyms in. So you look at your search analytics, which is super important. If you have customers that are searching your databases, then you have to run search analytics against your customer's telemetry to see that they're looking for Parker and Parker is not in my index. So if I'm an e-commerce site, they're going to leave and go someplace else. I mean, it's that relevant. Chris gave the example of Home Depot. Home Depot was one of my first largest customers. I've had Home Depot, Walmart, Target, Costco, Lowe's, a lot of different large e-commerce sites. And really those guys, if they're down more than a couple hours, it's millions of dollars to them. And if you look at like the top e-commerce sites in 2025, Home Depot was one of the top 25. But if you notice like Lowe's, for example, Lowe's wasn't. Lowe's is using open search and they're kind of outsourcing their stuff, where Home Depot is leveraging this type of semantic search and they're vectorizing their data. And it gives the ability to be able to do these searches and run against these large language models. And if you look right here, you can see that in my machine learning, right? And if I go to my trained models, by default, we give you several trained models. So we're going to give you ELSER model, which is our elastic learned sparse encoder, which is a text expansion model or an NLP type model. We give that to you by default, and most of the times we find that works very well. We give you a multilingual model, so that if you have somebody like, so what I see with some of my customers is I look at their deployments and I see they have like 30 different deployments or 30 different indices. And they have an indice for Chinese, and they have an indice for German, and an indice for Spanish, because they don't have a large language model to convert that. What we give you the ability to do is ask in any language you want, and that document can be stored in any language you want. So you can be Spanish and the documents could be English and we'll translate it. Or you can be Chinese, the documents can be in Chinese and you can ask in English and we'll translate that too. And that's the purpose of these models. And this last model, the language identification model, is actually going to identify the language that you're using and put it out. So that's kind of how, and these models are just the models that come on board, but we give you the ability, like Chris mentioned, to upload any model that you want. So if you went out to, like, for example, I'm sure many of you might be familiar with Hugging Face. It's kind of a repository or a library for language models. There are PyTorch models. You'll see there's a PyTorch models here. That's probably the largest by far model that type that's out there, I think. We can use others, but you can just use a tool called Eland, and Eland's kind of like an FTP tool, but it will just push those large language models up here. So essentially what you'd like to do is you'd like to take your model default, and if, let's say, you're a law firm, you'd go out and get an LLM that has like law terms in it, and you would upload it. And then if you want to train it, there's different parameters you can put, but you can also add a specialized dictionary. So if you're very specialized in something and you use specialized words or tools or something, let's say you're a Home Depot and you have a lot of specialized tools that are not typically in a large language model, you could train a large language model, add a dictionary file to it, and then upload it. And then once you upload it, then you get to use it. Now, one of the things that I wanted to show really quick that's a new feature in Elastic is Playground, right? So what we do with Playground is built into the solution. We give you a full environment to test out what you're trying to test from a perspective of, is this LLM going to work? Is this semantic search going to work? So right now you can see I already have an LLM connected. If I didn't, I could connect to whatever LLM I chose. Like Chris said, we don't care which models that you use or which vendor you use. And then if I look for, what was that, workplace? I think workplace docs. Yeah. So if I look for workplace app docs, right? And I say, okay, I'm going to ask that exact same question that I asked before. Can I put my puppy under my desk? This is me wanting to test out whether my solution is working or not, or well for me. And you'll notice that I can use the citations, include citations. So when I do that, it'll include the 3 document sources. So I get the exact document sources that it ingested for me to find that query. And then also it gives me the summary. I have the ability to choose whatever particular model that I want to use. I can change my prompt engineering to say, hey, if you don't know the answer of what I have, go out to the internet. And that's really important because I'm going to show you in the next example where I have it as a use case where I'm using the AI assistant, and I'm going to populate a knowledge base with internal information that's internal to my organization. But then if it doesn't have it, I want it to go out to the internet and try to resolve the issue, okay? So you can choose whether you want it to just stay internal or you want it to say internal and external.
Can
Now-
I add one thing real quick?
Yeah, sure.
So we also have RBAC controls here, so that depending on your privilege and what kind of data that you're supposed to be able to access, asking that question will only give you things that you're privileged to. So, you know, like if you're a manager level, you're gonna be able to see more information about employees and stuff, but if you're the employee level, you're not gonna be able to see that same amount of information, so.
Yeah,
Just wanted to add
So we,
that.
okay, because that's what I was gonna ask about was like, if we hooked it up to say our SharePoint site that had, you know, policies and internal documentation and all kinds of stuff, it can go based off of the users
yeah,
access then to only
Yeah.
pull, and you don't have to worry about.
absolutely. Right here. So notice right here, I think this is a question that I can ask. What is the compensation bands for engineers? Okay, so if I'm another engineer, I want to know if I'm getting paid the same amount as everybody else. I'm gonna ask that question, right? But as an engineer, it'll tell me, well, I don't know, right? But then if I click back
What is
and
our
I say,
salary?
I'm gonna change my level, and this is just an example to kind of like show you, but what we've done is we've created a user called manager, and we've given them role-based access control to the documents. And so what should happen should be that when it goes in here, I get the results that I'm looking for. So I think that kind of helps that as a demo of your question, right? To
Right.
answer, like, how can I use role-based access control? And what happens when you build a connector into a repository? And if you look back here in these particular indices, you can see that I have these connectors right here. These connectors can be used against, we have a bunch of default connectors. So you can see these are all the default connectors if you want to ingest. I had a customer the other day wanted to ingest their Outlook emails because they were looking for emails. So they just ingest it, but they don't want to do a lexical search because they kind of don't know what they're looking for. So they want to use kind of a fuzzy query, so to speak, and be able to use it. So they take it in, they run it through an ingest pipeline that converts it into those vectors, those numerical values, leveraging that large language model. And then they use Elastic to also do the same thing with the query. So these are all the default connectors, and you can build a custom connector if you wanted to.
So this connector just connects your Elasticsearch to that specific connector, meaning it is just a connector sitting in between Elastic
Yes,
and the actual thing, like, you know, maybe a Dropbox, maybe Confluent Data Center, right?
yes,
So does it fetch all the data and store that into index?
it does. Now, but here's the thing is that when you attach to that particular connector, right? It may be that all you want is the header information because you don't want the context. You want people to be able to search for the header and you want your indice to be light. So you have the ability to control which fields that you want to ingest and vectorize. Now, if you take documents and you're searching for a document, we automatically will chunk it. And chunking, if you're not familiar with it, is taking those paragraphs and chunking them up into paragraphs or sentences or whatever the solution will support and will overlap. So we'll take a part of the paragraph 1 and we'll overlap it with paragraph 2 because sometimes paragraph 1 will have context that paragraph 2 needs. And so we'll overlap that as well. So we'll do all that for you. And I guess the point is that when you go into like the playground that I showed you a moment ago, being able to have all that already custom built right here is really, really valuable because like I listen to podcasts all the time on AI and you'll have people coming out there like for a while Pinecone was really, really big, right? And now Pinecone's kind of not as big as it used to be, but they do like one thing, but they don't give you the vectorized database and they don't give you the ability to ingest your LLMs. They don't give you the ability to do RAG engineering and they don't give you the ability to test the playground. And you guys as engineers know that, right? Because you have people that are like focused on one thing and then you have to piecemeal everything together. To me, the strongest solution is something that has everything that I can use all built into one solution. Now, Elastic is not like click wizards and build out because it's a super flexible machine. So you have to understand how to do this. But I think Elastic has the biggest tool set together outside of maybe a hyperscaler where they're going to abstract that from you, right? And let you just do within the guardrails of what they want you to see. So,
Mark, we had a question come in online.
yeah,
Would security related data such as network or firewall logs, email metadata, audit logs, et cetera, be able to be ingested via connectors into indices where natural language queries can be used for observability?
That's an excellent question because that's exactly my use case, and we'll see that here next one.
Perfect.
But before we leave that, let's also look at our playground where we asked the questions and we said, okay, I actually want to see how to build the code to build my query. So all I have to do is click on here and it gives me the entire endpoint code that I have to use on my endpoint API to ask the query how to, what I wanted to use. And you can see I'm using the ELSER model ID and this model text is a query. Also, I can view code here and get the entire code that I need to do to build out this whole solution, the application code for this. So you don't have to be, you know, a data PhD engineer to be able to use the tool set. We actually are trying to make it as easy as we can for people to adopt, yet flexible enough to be able to do all the things that people ask. And one of the things I was talking to some folks earlier about is that Chris alluded to the fact of lexical and semantic search. So this is obviously semantic search because you saw the vectorized and the tokenized values and everything. In the lexical search, it's what we've commonly used when we used to go out to do Google search. For example, and I gave this example before, if I'm at Home Depot and I'm looking for a hammer, I'll probably use a lexical search because all I want you to do is return all the description fields that have hammer in them, and the ones that has the most hammer, I want to curate up to the top. Now with lexical search, some of the things that I can do is I can do geolocation filtering. For example, if you ask for a shovel and you live in Minnesota and it's January, I'm going to curate a snow shovel at the top. If you live in Texas and it's July, I'm not going to put a snow shovel at the top. That's curation based upon geolocation. I also can do filtering based upon your preferences. So if you have customers that have mobile apps and I know they buy, they're a certified electrical engineer, I'm going to give them certified products that I have. I'm not going to give them cheap generic products. So all of that is filtering that can't really be done well in semantic search, but it can be done well in a hybrid search. And in a hybrid search, we say, okay, I want you as a solution to tell me what the best response is. Should it be, if I say, I want to buy hammers, lexical search is obviously the best one probably. But if I say, what do I use to unclog my drain in my house? That's going to be a semantic search. So as a solution, I have to be able to weigh both response or all the responses I have and curate the ones that I think is the correct solution to the top. And so that's where you get into retrieval engines and actually being able to weigh the solutions more. And we give you tool sets. Now they're building LLMs for being able to do weighing of answers and stuff and curating them up. So that's all that kind of what we do as a search tool. And also I showed the connectors. We can do web crawler searches too. So let's say that I have a customer that's Red Lobster and Red Lobster is worried about their competitors. What Red Lobster can do is they can go out and walk their menu and they can build an index off their competitor's menu and they can monitor for any time their competitor's price change, so they can change that. So you can use a regular connector that we can use, or you could use a web crawler, and you can web crawl. You can web crawl your internal websites. So for those of you that have like a bunch of internal websites for people to be able to search internal things, you can actually web crawl those, vectorize the data, and now your people can search for semantically for the data that they're looking for instead of having to search lexically. So those are two ways, and the other way is you can do APIs too. So all that data is brought in, and when I use these connectors, if I look at my indices, and I looked at that workplace doc indice, the documents are there, but what we do is we build a pipeline, and the pipeline is going to say, hey, what machine learning inference pipelines do you want to use? Meaning what tools do you want to use to turn those values into numeric to numeric vectors. And so you can see right here, this one is just using the ELSER, which we saw in the playground, but you can connect to whatever you want. So you have to connect to your data, and as the data is connected and being brought in, you want to vectorize that data, and not the whole thing probably, because you don't need to vectorize a timestamp, right? And you don't need to vectorize maybe the author's name, but you want to vectorize what's valuable to you and then put that in the indice. And then when you do the search, it'll search it. Does that make sense? Any questions?
So when you talk about different searches, how do we know which searches would be useful when you don't know what kind of questions a customer is going to ask?
That's a great question, because that's where we are right now. Is like, how do we weigh which is in a hybrid solution, you're gonna have the ability to do lexical queries and semantic queries. And how do we know that? How do we know which is best? A lot of it is human intervention, where we start training our models to say anything like this or similar to this is going to be a semantic search. And then you can also boost values more than others. So let's say I do a semantic search, but I'm Home Depot, and I use Home Depot a lot just because I've worked with them so much. Let's say DeWalt is a partner that is a higher priority than Black & Decker. You can say that no matter what happens, I always want to boost this particular value up higher than others. So some of it right now, and like I said, we're kind of in the process of building out LLMs specifically for weight, for ranking LLMs. And those ranking LLMs are built to learn all the queries that people ever use and what the best result was, and then give you the ability to install those into your solution, whether it be lexical. But you don't want to do lexical only, but you do want to do lexical. I have customers that are like, I have a huge customer in California that does timeshares right now. Florida that does timeshares. And they definitely want to leverage lexical, because if I say I want a ski out condo in the mountains, they have to go through their entire database and figure out which places in the descriptions are ski out to the lifts, so that they can return the right result. You can't do that with lexical, but you got to use geolocation filtering on that, because you want to make sure that you're returning places that maybe they say, I want to go to the Rockies or something like that, then you have to use geolocation filtering.
Yeah.
So we have a guy, he's a distinguished engineer. His name is Mike Helderman. He's actually a PhD. He's a doctor. And he says, like, the hardest part of any web page is this little part right up here, that search part. That's the hardest part to code. Everything else is easy. So you can understand the complexity of it, but that's why I think so many people use Elastic, is because we give you the entire tool set.
You had an issue like that too, where doctors they would not want to type out like five words, like hyperthyroid something. They were, I just want to type in like the initials for it, HTTP, and return that, and like it would return that related illness through like, I don't know, 3 gigabytes of the documents, and they're searching through all that stuff right there. It was insane trying to work all that out, but.
Yeah, no, you're right. For Elastic, like 5 million documents is super low. I just had a customer today that had 660 billion documents in their indice. So when you're searching with Elastic, we give you the ability to do things like header caching. And with header caching, you can put frequently. Elastic, the way we divide up our data is we shard it. And I think the easiest way to think of sharding is kind of like striping, disk striping, right? We shard it across multiple nodes. And the reason why we do that, there's 2 reasons. One is because we're multi-processing, we can search across multiple shards. But the second thing is, if we're searching parallel processing, we can search much faster. So if you take a telephone book and you say, Chris, I want you to search from A to Z, it's going to take him forever. But if you take it and break it in half, he's going to search it faster. And then if he says, Chris, you search A to N and Mark searches O to Z, and I break it in half, well, that's multi-processing. And so what we do is we give you the ability to shard out all these 11 billion documents and put them on different nodes so that you can search them really quick.
Yeah.
So let's look at one other use case if we can, and then we can go to questions and look at anything else that you're interested in. So here's a use case that I had for a customer, a real customer, and if I said their name, you've probably used them before, not Home Depot. But this customer was interested in network telemetry, and they were using a Cisco product called Cisco Identity Service Engine, and they were doing 802.1x authentication. So they were trying to go to zero trust model on their network infrastructure, and how do they actually make sure that people are logging on to switches and wireless. For example, if Jeff logs into Asurion, he can log onto the Asurion, any Asurion wireless, but I can't. How does that work? Because he never types in his password. It's using 802.1x. However, more and more people are wanting to put that into switch ports, because if I walk in here and I find an Ethernet jack and I jack in and I get an IP address, I can start scanning their network. So they use 802.1x. The problem is it's a very tedious, anybody ever try to install 802 or move towards 802.1x? It stinks. I mean, it's really difficult, right? Trying to figure out the policies, trying to figure out what's wrong. So this customer had executives, and the executives have laptops. So when they go in their office and they plug in their workstation, everything, I mean, their docking station, everything works fine. But when they go to the cafeteria or they go to a meeting, they can't get connected. So they're ticked off. So their team is like looking through their ICE documents and they're just looking through logs. At Elastic, we never want you to have to look through logs. Looking through logs is old school. We want the system to be smart enough to tell you. So what I did is I took their data, and you can see in Discover, which actually shows particular indices of data. I'm looking at a particular data right here, and I'm going to use these right here. And you can notice that within this network telemetry, I have all this data. And if I do ICE, which is a Cisco product, you can see over here that I'm getting all of these different telemetry fields from ICE. And what that looks like is this is what that looks like over here. Let me slide this down a little bit. So over here on the right-hand side, these are all the fields. This is very important because what this is this is the difference between, let's say, us versus a Splunk. Splunk is considered a schema on read. So Splunk, when you ingest data, it's super easy to get it in because it just takes it all in and throws it in the file system. It doesn't parse, it doesn't do nothing. But then when you query it, it takes it out and it normalizes it. So it builds a schema on read. Now that's good because you can get data in super fast. So you can pretty much throw anything at Splunk, it gets data in. So when we do POCs, it's like, how come it's so hard to get data into Elastic? Well, what we do is we use integrations like an Apache integration, and then that integration is listening for the data, and then it has to normalize the data. And normalizing data means put it in Elastic on a schema. Now the value of this is if I put it in a schema, then I can vectorize it and give it those numerical values because I know the observer product, or let's say there's a message field that has a bunch of information. I know I want to tag the message field and vectorize it because that's the field I'm going to do a semantic search on. So because we normalize the data before we put it in, it leads itself very nicely to being able to use machine learning and AI assistant. So let's look and see if we can help this person whose CEO is about to fire them because they can't get onto the network.
Yeah, and that schema is the same one that Open Telemetry adopted for their project.
So if I look at this, I see right over here some really cool things that I can leverage. The Cisco ICE error log message. So I'm going to use that, right? So I go into machine learning, and within machine learning, I create an anomalous job. Now to create a machine learning job in Elastic is very easy. You just go in here and you use logs. You're laughing. Did you all think it wasn't easy?
No.
Oh, okay.
Right now we are playing with anomaly detection jobs in open source. That's the reason I just.
Oh, okay. Okay. So we have a wizard, and a wizard gives you the ability to create single metric, multi-metric, population, advanced, geo, machine, rare, whatever you want, right? But for time's sake, let's just create a simple single metric machine learning job. So I would pick my time range. Now notice this gives me a time range, or I could use full data set. I'm going to use full data set here. This is the whole data set that I have. Now, the reason why you would maybe want to pick a time section is because if you're running machine learning, for you guys, if you're running machine learning, one of the best ways to run it is from the beginning is what's called a supervised machine learning job. And a supervised machine learning job says, I know the telemetry. I know the time that problem had. I know this particular field. If I had known about it, I could have created a machine learning job. So I'm going to create a supervised job. If I don't create a supervised job, then I use what's called the unsupervised mode. Unsupervised mode means I'm just going to take my whole data set and just look for anomalies. So that's what we're doing here is we're going to use a whole full data set. We're going to click next. We're going to choose the fields that we want to count against. Like this one will be a low count, high count, whatever, a rare count, whatever. I can use whatever I want. And then we have this bucket span. The bucket span says, what span of records do I want to look at? So this will be different depending on your machine learning job. For example, how many times a user logged in over a week will be a 7-day bucket span, right? But CPU utilization, high spikes in CPU or low spikes in CPU or high spikes in memory or any metrics, that will be much shorter, right? If you don't know what it is, you can just click this button and say, estimate my bucket span, and the algorithm will choose the best model based upon what fields you choose. Then I can go in here, click next. There's some additional settings, some advanced settings to say, I want to build a React front end or web front end because I don't want people to go into Kibana. This is Kibana, my user interface. Or you can say, I want this job just to run on weekdays because weekends throw the whole anomaly off. So you can choose whatever you want to there. And then once it's done, you just see if I can shrink it down here. See if I can do it. That'll work. Once it's done, over here on the right, which I'm not able to see, it'll just say save and create the solution. And for some reason, my screen is not working because I've increased it. I'm wondering if it's not a Zoom thing. But what it'll do is it'll show up right over here. So now your job shows up over here. So here's that ICE job right here, okay? So notice this is the ICE job that I created using that same methodology. I ran it across 11 million records. And then right here, if I go into Anomaly Explorer, I created these influencers. So partway through, you can select what influencers you want. For me, what I thought was important was, remember, I had those ICE login failure reasons right here. And I wanted to know the host names they work. So I thought it was pretty cool because I was like, look, already I'm firing off these machine learnings and look at this top one. These two devices are not in Active Directory. There must be a problem with your Active Directory server. And they're like, duh, no, those are our network scanners for security. We don't have any Active Directory names on those. I said, oh, darn. They said, but the next one, that Workstation 5, which wasn't the name of it, but I kind of protected the name of it so you can't tell who the customer is. That's one of our CEOs. And his failure login reason was because his shell profile has denied access. So somebody's messed up his shell profile so that when he goes into wireless mode, he's getting denied access. And they're like, this is so cool. This will help us out so much because look at, you've got the failure message. Now we don't have to go through logs. We love this. And I said, you know what would really help is if I could actually connect one of your playbooks to these, but I can't do it in this particular screen. So what I did is I went out here to observability, and I went into observability. In observability, I can create these rules. And if I create a rule like this particular ICE rule, well, if I create a new rule to show you, I can create an anomaly detection rule. So I can build a machine learning job, and now I can build an AI observability detection rule, and let's see what I can do with it. So if I go down here and I go to my alerts, I have an alert right down here I can pick. What is this one? Okay, so here's one of the problems that they had. This is the Active Directory one. We'll just use this one. So notice 86411 failed to fetch user from Active Directory. If I actually go down here and say, let's look at the alert details, immediately it's going to go in and it's going to give me the ability to connect to this AI assistant. Now, this AI assistant is by no means a chat GPT because I've gone and I've pre-configured this AI assistant to have a knowledge base of any problems I've ever had. And I can do that by connecting to my ServiceNow directory. So I can connect to ServiceNow. I can ingest all my ServiceNow tickets that I've had in the past. I can vectorize them. So now I don't have to do a lexical search. I can do a semantic search, and I can pull in anything I have. For this particular customer, they use GitHub, and they put all their playbooks in GitHub. So I could just create a connector to GitHub, pull in the data, vectorize it. Now when they have a problem, it's telling me exactly what it is and how I should move forward with it, right? And if I don't know what it is, I can go down here and say, how do I ensure that my ICE server is connected to Active Directory? Because maybe that's what I think is the problem. And what should happen is it's just going to look at my knowledge base to see if I have anything inside. And if not, it's going to go out and download me a step-by-step way to check that and verify it. Now, if I look at this AI assistant up here and I go in here to manage knowledge base, just for simplicity reasons, I actually just added a manual knowledge base of those error codes. And somewhere down there it is right there. Here's the failed to fetch users from Active Directory. So you see what happens here is that now we can leverage the power of your data, because if you have a barcode or scanner that like Home Depot has, when you go in, you scan the barcode to pay for it. If that scanner's not working and the sales engineer calls help desk to say, the scanner's not working, what am I gonna, I think it's broken. Immediately that scanner has an ID associated with it. The wireless access point that it's connected to has that same ID. They're both feeding telemetry into Elastic, and it notices that there's an anomaly on that particular ID in the wireless AP, and it says that wireless AP is shooting a bunch of disassociations. And why is that? Because they moved around furniture last night and somebody put a shelf in front of the AP and it's blocking the signal to it. So you can see how we're going to decrease mean time to resolution, leveraging machine learning and AI together. So that's kind of my demonstration. I have a ton more, but I won't bore you with them. But any questions on that? That look like something you could use, valuable to you and work? Any other use cases that you can think of?
I would like to point out, we do the same thing with security. So you can review security events and logs using natural language, much like this. They go hand in hand.
Yeah, actually, one of the new security features that we've had out recently is an alert AI assistant. So anybody that's ever looked at a SIM before in a large organization knows it's almost a waste of time, because you come in, you got 30,000 events. And how do you sift through those 30,000 events? What we'll do with our AI assistant, and we can show this to you. As a matter of fact, you can go out to Elastic and demo it yourself. We'll take all those events. I think we use 30. We'll take those 30 events and we'll summarize those down into 3 separate alerts, where we can say that this person did this within the attack chain. They executed an Excel spreadsheet, and that Excel spreadsheet had some type of dynamic library in it. When that dynamic library launched this particular thing, which did this. So instead of each one of those generating an individual work and you having to stitch that back together, we do it for you.
We also are able to automate creating tickets for this stuff too. So even from an observability perspective and an MTTR kind of thing, if you guys have like ServiceNow or something like that, the assistant can actually populate a ticket for you. And so that really helps your analysts speed up responding to an event or some kind of problem that might be out there.
Exactly. So I'll finish the demo up with the demonstration up with the fact that we can do all of this for you, but we give you a lot of built-in functionality as well. So within the security perspective, if we go into, let me switch from read write access. This is actually RBAC in action there, because I didn't have access to it as the default. But we give you, I think somebody was alluding to the fact of like, what's the difference between yours and the detection rules of the open source solution and stuff. I don't have any rules on here, unfortunately. I'd have to go into this, but we have over like 1,000 rules. And within our dashboards, we've populated you with like all these different overviews. A MITRE attack framework is on the right solution.
Something to point out with the rules as well. A lot of platforms have black boxes around their rules, right? You don't know what exactly is triggering the rule. Is it a threshold? You know, like what's it looking for? All of ours are open. So you're able to see exactly what the criteria is for the rule, and you can actually go in and customize those too. So that's been a really big thing that a lot of my customers love. You know, we don't have any black box stuff in Elastic.
Right. Good point. Thank you.
You asked for a use case. I was wondering about predictive failure analysis. You know, if you're able to then look at if you run across any of those kind of use cases.
We do, absolutely. One of the use cases that I was working with was with Cox Communication, a big use case on their fiber optics.
Mhm.
They were trying to get predictive analysis of when those fibers were going to burn out before they did. So we ingest telemetry, and you can see like certain trace codes of like, it's impossible to see unless you're running like a machine learning job against it, but they can predict when their fiber optics are going to run out before they do.
Okay.
That's one use case. I know we have 1 billion of them, but people use it for that particular thing too as well.
Okay.
Yeah, so this is an example of a summary of 108 different alerts, and I can just go into attack discovery and take those 100 alerts and generate. I don't have access here to this one because I don't have admin privileges, I guess, but I should be able to just click this, and all those different alerts will be summarized directly into, you know, which ones are related to which ones, but we give you the ability to actually drill down into these and look at I can add a note into the ticket like Chris talked about, or I can investigate the timeline of it right here, and I can do specific queries on whatever I want. If I wanted like a particular user ID or a particular host name, I can just add that up into the query and it will show me anything with that. So we have all the typical threat hunting functionality that you would expect out of a solution like this. But the nice thing is, I think we add AI assistant into it to help you when you see these rules, to be able to not only understand them, but also how to mitigate against them and summarize them into less rules to keep your your SOC analyst sanity.
Mark, we had one question online. Does the platform have agent capabilities to react to automated incident response? So
Yeah,
think like model context protocol, like plug in all the things and build automation from some of what the agent would otherwise parse out and be able to intelligently act.
yeah. So that's kind of, in my opinion, a bit of a two-part question. So I'm gonna go in and first show you the agents first, okay? So what I'm gonna do really quick is I'm going to go to my deployments here real fast, where I have admin privileges and won't be locked out.
Well, and I would ask a little bit about the use case specifically for those agents too, you know, like, particularly is it security focused or observability focused? I don't know what you're gonna show, but, we've got integrations with like a source.
That's what I'm gonna show.
Tines, for instance, and you know, Tines is really powerful, but.
Right. So if you're looking for automated response, we actually partner with people like Tines or, there's like 3 or 4 different vendors out there.
Who's the AI ops company we just bought? That's gonna be for observability. That's gonna be
Right.
an automated response thing, so.
Right. But the first thing we want to talk about is like, how do you manage these agents and integrations? So we give you a tool, and this is something that's different than from the free version. We give you this tool called Fleet. And what Fleet is it gives you the ability to deploy all these agents that we're talking about. So you can see some of these agents are actual, that particular agent is a desktop. This particular agent is a container out on GCP. This agent is a VM.
When you say agent,
Yeah.
what do you mean?
So you're familiar with like an EDR agent, like a CrowdStrike agent or an agent that you put on your machine.
Mhm.
This is the agent. However, some agents, and we have to have an agent that's listening for the telemetry and normalizing the data, right? So first we deploy an agent, but when we deploy an agent, that agent has to have an integration. So you deploy an agent and agents can have multiple integrations. And you can see here, for example, somebody asked Apache.
Is this the agent that is being framed here, though? I think this person is asking about like AI agents, like agentic
Yeah.
artificial intelligence.
Right, so what I'm explaining here is like, you have to have an agent on the machine to be able to mitigate against attack, right? So if they want to like stop an attack from like they see an attack and they want an agent on the machine, they want that machine to be isolated. This is what you have to have from that perspective. And then the AI connector is the aspect where you have an AI agent to help you with the rule sets to understand that. Now, when you create a rule for something like password broken or somebody did something, somebody logged in as admin, that's a rule that's in SIM. That rule that's created at the very bottom will have an action, and that action will be whatever you want it to do. Now, we don't have the ability for AI to say, AI, what do you think the best action would be? I mean, I don't think anybody's there right now, and I'm not sure that we want to be there, right? But yet, but we do have the whole framework for you to deploy an agent that can isolate the device, and we have the ability to leverage an AI agent on the platform to interpret what a rule means and how to mitigate against that. But that purpose of like saying, I'm going to create a firewall rule to prevent that, that's a source solution. It's kind of outside of what we do. I hope that answered it, but maybe I didn't answer.
I think the question is more of about, so for example, you have a lot of alerts that is being created, right? So, and you do have some data behind to analyze those alerts and see if this particular agent can resolve based out of the historical data, if it is a common alert.
Yeah, the same AI connector that I used against the use case for network telemetry can be used in security too. So the AI assistant should have some type of repository that it goes against to say, yeah, we've seen this before, how do we mitigate against it?
Well, so we've got some automations. I think that's more of the question, right? Is like, do we have automations that trigger off of the alerts? Is that the question? Like, I'm trying to understand.
That's, I think that's what's being sought after here. Like,
Yeah.
there's some autonomy that is being built into the, like, the very overloaded keyword agent. Agent in this context would be like, I have an autonomous AI that can understand, it's constantly listening and reading all the data. And when alert is triggered, it's going to fire some automation based on what it's decided is the next best action. I like, if I were to do that on my laptop, I might give the agent free will to create a bunch of code and create files on my file system. So I asked it to do a thing. I don't just want the answer back, like, here's what a test might look like. I'm going to have it write test files and keep changing my code base until tests all pass. That's like a developer use case. The security use case here that's been requested is, with all this telemetry that is being ingested, can you understand that an attack is happening and then mitigate that in real time?
Yes. So we're able to, number one, use the attack discovery piece, which is basically a large language model, grabbing all those events and summarizing them for you so you understand what's happening first of all. But then our agent that Mark was trying to show that goes out to a host, it's got some capabilities of doing immediate action based on that. And so, like, for instance, say like malicious code is being downloaded, right? That's an alert you get. We can actually cut the host off from the rest of the network. And so we can do a few things like that where you can automatically trigger an action based on whatever alerts they are happening that you care about. But yeah, that's not where we have most of our functionality, but we do have a few ways to respond to certain alerts.
Yeah, and alert action, it's not really going to allow the system to do things or change things on the end user nodes. It's only going to allow somewhat of an isolation aspect of it to
Got it.
isolate the device, which I think where most of the people is now. On your code development, I was looking for the exact example that I wanted to show. We have what's called universal profiling, and what universal profiling does is it goes through your code and it looks for processes or running like libraries within your code that are not optimized. For example, the example that I was looking for was, we create a sample of code with a for loop, right? And we initiate the variables. Anybody that codes knows you initiate the variables not before the for loop, not in the for loop. But we run one sample of code where we actually initiate the variable inside the for loop, which causes, it's an interest calculator. So we reinitiate the variable for the calculator inside the for loop, which causes that process to go crazy. With the AI assistant, it'll know that that particular process of code is not optimized and will suggest optimization code for that to make it fix. So from the developer's perspective, we have Walmart is a huge user of our universal profiling code. As a matter of fact, we have a customer that found out that their hyperscaler was running an agent on all of their workloads in the cloud without their permission. And that agent was using up like 1/6 of the capacity of the compute resource. So for every 1,000 compute resources,
That's a coin.
yeah, they were using it, and they went back and got compensated from. Now, why a hyperscaler is running an agent on your VM, your Ubuntu container, I don't know. I don't know why they do that, but the fact is that particular agent is taking up space, and they're actually losing money from the hyperscaler because of that. And they leverage universal profiling for that.
Wow.
Where is it doing the code optimization? Is it looking at the nodes that the code is running on as it's running, or is it looking at like source control or?
Yeah, that's a great question, because like, if I have compiled code, I can't look at it, right? But we actually have a compiled code linker. And so we are actually right next to the CPU.
Okay.
We're running EBF, and we're right next to the CPU on the sidecar, and we're looking at every call that goes to the CPU for anomalies on the CPU. And then we have dynamic library that links to, if it's compiled code, to all the libraries to find out exactly what that particular library is. So we can run with, so there's a free version you can run out there. So if you're just running open like Java or Go or something like that, you can run universal profiling on the free version. But if you want to actually run it against compiled, you have to pay for it because it took tons of hours of development for us to be able to link it.
How do you link that back to the symbols in the code? If you're looking at it as it's hitting the kernel, right? You've got something looking at the kernel, it sees that this is not optimized, it's pointing you to a library. How do you then tell the developer that's line 10 to 20?
We'll look at like routine calls that are actually being pushed and analyze that whole call. And not say that particular line, we'll say this particular call is unoptimized and it looks like this particular feature potentially. Another good example would be like if you were using super secure cryptography to create a hash or something, we would see that your call to that cryptography was super long. And we'd look at that code and analyze it and say, okay, we wouldn't say you probably don't need this, but we would say because you're using this particular 256 AES hash, it's taking longer than it should. Potentially you might want to use a 128 or 64 or whatever, depending on, you see what I mean? So that's exactly how we're looking at it.
Okay. Thank you.
Yeah, and then so if you go into your solution and you go into observability, universal profiling is right here. And this AI assistant's popping up to say, set up my AI connector so I can make a universal profiling experience better. But then it will start building, if you're familiar with flame graphs and functions and stuff, it'll start building data based upon your routines that are being sent to it, whatever telemetry is being sent to it. So I don't have any flame graphs on it, so I was looking for that particular one that had telemetry in it, but it's kind of an overview that you can set that up. Actually, believe it or not, have an agent that you can run on a laptop for it and you can download too, but it obviously doesn't have the compiled code library on it. But if you want to run it on a laptop, you could too. We have customers who do that.
What other questions are there?
I have a question.
Sure.
Can you connect that to your Outlook and read all your emails?
Yeah, it would be nice if we did an AI to summarize all my emails into what's important.
2,900 emails.
Oh my
Yeah.
goodness.
We can have a bot, right? We have
Yeah.
built a bot in Azure and small bot in the Slack where we just say a thread,
Just read all your
summarize
emails.
this thread and it just gives us a summary of 3 lines.
Yeah, there is tools right now for that are actually doing that. They're summarizing your emails and trying to find stuff that's important for you to respond to.
Was this?
Jeremy, was there another question?
There's another question just popped up. What protection mechanisms are in place to detect malicious actors who purposefully add weight to incorrect answers? Or data poisoning kind of question.
Somebody sabotaging search results.
Oh, yeah, so the actual platform itself is obviously, the data is in transit and at rest is encrypted. So you can't read the data in the Elastic Stack or in transit. But then when it's on the actual stack itself, there is security against at a document level, actually at a field level, that you can apply to it to make it so that people can't change anything on it. And also we've had this a lot where people have asked to turn on audit D in their XPack security. So anytime someone changes a document, audit file, which you can run against an ML job to see it. So it's pretty secure. I mean, I think the biggest problem that we have is that people just will get an open source one and deploy it open and not secure because they don't know what they're doing and then they get in trouble. What happens is people will download a trial, they'll start open source, they'll put all their data on it, become critical for the company, and nobody's ever verified it for security or anything. And we see that in cloud app sprawl anyways, right, all the time. So
I think this question is more about an inside threat, somebody who goes out and they purposefully try and screw up the search results, right? Like changing
inject
the
data?
ranking.
So realistically, it's only reading whatever data you've got, right? So the only way that could happen is somebody was getting into your source data, so
yeah, so
whatever you were reading from.
So when you deploy an agent, you have to use an API key to make sure that just not any agent can talk to Elastic. So you use API keys when you deploy the agents. So it knows the agent has been deployed by you. So in that solution fleet that I showed you, it would actually deploy and it deploys a key. And then that key is sent out to the agent. And then when that agent tries to enroll with Elastic, it verifies that the key works. Plus you can use certificates as well. So there's 100% verification that just some anonymous agent can't inject data in. Now, if you got on the machine and you were able to go into all the files and all the events that Elastic listens to, and you're able to change them, you're kind of screwed anyways, right? Because if you've got that kind of privileged access into a device and you're changing files, but what should happen is an ML job should pick up that as malicious activity because data is being changed and stuff. Unless you're doing something totally crazy and you make the data look perfectly what you know Elasticsearch has. So it's a little tricky. I think there's probably easier ways to, I think a phishing attack is probably just a lot easier. Hey, open up this email that has your job, your job, your pay increase on it, you know? But hopefully that kind of helped them understand the security measures that are built.
Chris, you can come off mute if you'd like, but if you thumbs up, thumbs down, does that help answer your question?
In a way it does. This question came up earlier when I recall that if I heard correctly that there was the ability to provide feedback to the results of the natural language queries. Like the thumbs up, thumbs down kinds of thing. And it sounded like, depending on how someone clicked those buttons, it would weight future results. So if that's not the case, then my question is moot. So I was thinking if somebody purposely asks a question and gets the wrong answer or whatever, and keeps thumbs upping it or whatever, to poison additions to the model.
Oh, okay.
I've
So
seen
you're
that,
talking
actually.
about poisoning the actual LLM.
Mhm.
Yeah. I mean, I'd say that there's, and then we kind of maybe call it kind of a variant of hallucinations. And that's always possible unless you're using LLMs that are built internally. And those LLMs point to exact knowledge bases where they can't go out to the internet to be poisoned, right? So if I'm looking at like a SharePoint document, like I showed you the pet policy, that it's hard to poison that pet policy because I'm looking at exact there. And in the prompt, if you remember, I told the machine, if the answer is not in this document, don't go out to AI and don't just say you don't have the answer. So I would guess that would probably be the best way. And I think there's a lot of I think that's a great question because there's a lot of potential healthcare customers that are trying to leverage AI right now. And they're trying to say, how do we guardrail this? And that's essentially the terminology, like how do we put guardrails on our AI so it can't be poisoned? And essentially probably the best way to do that is at the beginning, try to leverage documentation that's not altered or whatever by anyone.
But, and I think what he was saying too is, and I don't remember, did you have like where you can say, were these results good or not? And you say yes or no. So if you're saying.
Yeah, that's something you see out more on ChatGPT because they're trying to train everybody's model and you can potentially poison stuff, right?
Right.
But for customers that
Yours.
don't want to connect to the internet because they're worried about that, which we have a lot of customers like that, we recommend running an on-prem LLM model.
All right.
I did see at my former employer where they had a very poorly worded question, which is, and we actually did a survey of like 1,000 employees, and half of them thought what they were answering with the smiley face was, your search was really good. Like this was a really good use of AI. And the other half thought was, I didn't like the answer, right? Like, because it was about job searching. And so it would come, so they were scoring either, it was exactly dichotomous of the actual answers. They had to actually throw away all the answers and start over. Because, yeah, because the feedback loop was ambiguous. And so they were scoring bad data as good and good data as bad.
Yeah.
Yeah.
Yeah, you know, it's interesting you bring that up. I have a demonstration where we leverage natural language processing. And there's like within natural language processing, there's text expansion, there's things like zero shot. And people like Airbnb use that a lot. to be able to say, I stayed at this property and it was really quiet, but the room was a mess. So is that good or is that bad, right? So some of it requires you to actually kind of go through and look at your models and stuff and really train them up a little bit. But for the most part, quite honestly, out of the box, you're gonna have a lot more functionality than you did before. Like, how does Airbnb read all the comments and their feedback on things like X or something like that, you know? We have a lot of customers, quite honestly, that are ingesting social media sources, and they're just ingesting and they're running zero shot against those and trying to figure out what their customer sentiment is. Things that they used to have like 100 people doing, now they have 5 people doing.
It's pretty cool.
Wes. Thank you. Well, we appreciate y'all being here. I hope that you're as excited about Elastic as I am. I love the product. Like I said, I came from 17 years at another vendor, and you know, I just think this is really cool, the AI and how we're leveraging it. And I think it's really going to help us be able to reduce mean time to resolution, right? Or mean time to innocence, I guess, for network engineers and for SREs and everything. And we'd love to be able to follow up with you if you have any other questions, and we can leave our email addresses and feel free. Some of you are potentially our customers like Assurian, and some of you are, we are obviously have an account team that we can kind of connect you with.
Yeah, so I'll leave for anybody who watches this later or anybody in the room. Like if you join in our Slack channel, OWASP Nashville Slack channel, and I'll make sure we all get the links to that again. I can pass on, if you'd like, your information to Mark and Chris and help you get in touch with Elastic if that's where you'd like to go.
Thank you, Joe.
Yeah,
Thank you for hosting us. We appreciate
All
it.
right, yeah, thanks, everybody.
Thank you.
And then real quick, our next meeting is not July, but August, because we were trying to do every other month and then we ended up with August, September, October. So I think is August the Ox security one?
Yes. Yeah, so we'll have Ox security. I need to remind myself of the subject matter. Honestly, they have shared. It's on the meetup page, but it's the second Wednesday in August. I don't remember the date off the top of my head.
I'll pull it up. But yeah, so please come out again, tell your friends. The dark side of AI, developing insecure applications in minutes. So that's gonna be around vibe coding. So that should be a good one as well. So looking forward to having everybody at that one.
Second Wednesday.